Hey guys, welcome to 7.1. We're going to talk about zero and negative exponents today. And our essential question, what do zero and negative exponents do? So let's start off by completing these tables here. Um, and we can really just use a calculator for this. Uh, we grab a calculator and we just do 2 to the fourth. You're going to use the caret button, and the caret button looks like an upside down V. Uh, and you'll go 2 to the fourth, and that equals 16. Okay, 2 to the third, this is really 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. Okay, 2 squared, 2 times 2, 4. 2 to the first is just 2. 2 to the 0 power, anything to the 0 power is 1. And you could plug that into your calculator and you'd get 1. All right, now if we do 2 to the negative 1, that's going to get us, your calculator might say 0.5, which in fraction form is 1/2. Okay, now if we do 2 to the negative 2 on your calculator, you'll get the decimal 0.25, which as a fraction we know is 1/4. Okay, so just kind of take a look at what's happening here. We have 2 to the first is 2, 2 to the negative first is 1/2, where the 2 is on the bottom. 2 squared is 4. 2 to the negative 2 is 1/4. Okay, so let's see if it holds true for tens. 10 to the fourth, a shortcut for tens is that it's the number of zeros, so we have 4 zeros. 10 to the third would be 1,000 because 3 zeros. 10 squared is 100. 10 to the first is just 10. 10 to the 0 is 1, or in other words, 0 zeros. Now, based off of our observations here, 10 to the negative first, I would presume to be 1/10 if the pattern holds true. So let's do this on our calculator. 10 to the negative 1 gets us 0.1. Now 0.1 turned into a fraction is 1/10. And so this would be 0.01, which is 1/100th. All right, so that's kind of an intro. And the key point is this, is that anything to the 0 power is 1. Okay, those are called zero exponents. Even 0 to the 0 power is 1. Now, there is some debate amongst the math community of, oh, this should be 0, oh, it should be 1, and whatever. I'm on the side of that it's 1. Anything to the 0 power is 1. Okay, so you could have 1 trillion to the 0 power is just 1. All right, now, we had these negative exponents, right? Negative to the negative 1 to the negative 2. Let's just for fun call those angry exponents. Really, those are just exponents that don't want to be where they are, if we want to put it that way. And so if we have a number to the negative n, let's just say, it means that it switches sides of the fraction bar. Okay, so this is up top. It has a negative exponent, and so it becomes positive if it's down below. Okay, similarly, if the negative exponent is in the denominator, is down on the bottom, then to make it a positive exponent, you flip it up to the other side of the fraction bar, which is really just x to the n. Okay, and we'll play around with these. So, what is the simplified form of each expression? Well, I know that 6 to the negative 2, I can make this positive if I just do 1 over and then move this down to the bottom. It becomes 1/6 squared. Okay. Now this, we can reduce this even further. 6 squared is 36. So that would be my answer. Okay, now for this one, negative 9.3 to the 0 power, anything to the 0 power is 1. Okay, here I have 1/5 to the negative 2. Remember, when it's negative, if I flip it to the other side of the fraction bar, it becomes positive. Okay, so 5 squared over 1, which now that it's 1 in the denominator, I don't really need it, and so it's just 5 squared. which is 5 squared is 25. Okay, now this is a whole bunch of gobbledygook, and you might be inclined to turn to your calculator, but then you realize all of that is to the 0 power, and so it's just 1. All right, now we're going to simplify as best we can, but we don't have numbers here, so we're just going to get it as simplified as we can. That means that there's no negative exponents and there's no 0 exponents. And so what we're going to do is if it's on top, this is really all over 1. So if it's a negative exponent, we're going to shift it down, or if it, in this case it's on the bottom, we're going to shift it up. All right, so the 3 stays put. And then we have a to the negative 2, so that sends it down to the bottom as a squared. And then b cubed is positive, and so we can keep that up on top. Okay. Technically, there's a 1 out in front, right? But we don't necessarily need to write that. All right, and so our final answer would look like that. All right, now here I have a negative exponent in the bottom, and so I'm going to bring it up to the top. We're going to have x to the 6th over 1, which is just x to the 6th. Okay, down here I'm going to just take it as I see it, right? And so the 5 stays up on top. And then I have x to the 4th, that's positive, and so that can stay up where it is. Y to the negative 6th, I need to bring that down here then. And then z to the negative 2nd, I also need to bring that down here. And there we go. All right, now the last one here, basically just go through. Okay, so 3 to the negative 2, that has a negative exponent, so I'm going to bring it down here as 3 squared. X to the 4th is positive, so I'm going to keep that where it belongs. Y to the negative 6th, okay, I need to bring that down here, y to the 6th. And then z to the negative 2, I need to bring that down here, z squared. Okay, now we have to deal with the stuff on the bottom. 2 to the negative 3, that needs to come up top. 2 to the 3rd, and then p to the 5th is positive, and so that just stays put where it is. Okay. Now we can do a little bit extra with this one, because I know that 2 to the 3rd is 8, and so I have 8 x to the 4th on top. On the bottom I know 3 squared is 9, and then I have y to the 6th, z squared, and p to the 5th. And that's as good as I can get it. I would also look, can I reduce these down at all, my numbers out in front? I can't. 8 and 9 don't reduce down, and so this is where I end up. Lastly, what's the value of that when, I guess not lastly, we got one more after this. Anyways, what's the value of this for when a is negative 2 and b is 1? Well, first off, I want to make sure that all my numbers are where they belong. So 2 can stay on top. A squared, a to the negative 2 needs to come down to the bottom and become a squared, and then b to the 4th is fine on top. Okay. Now I'm ready to plug my numbers in. Now that I have it simplified, now I can plug my numbers in, and so I have negative 2 for a. Remember your parentheses here, they're very important. Okay, and I know b is 1, so I'm going to do 1 to the 4th. So I'm just plugging in negative 2 for a, plugging in 1 for b. Okay, and now we just solve. 1 to the 4th is 1, 2 times 1 is 2. And then I know that negative 2 squared, negative 2 times negative 2 is 4. Okay, now 2/4 I can reduce down into 1/2. All right, this one here, 5, simplify it first, so 5 can stay on top, x to the 4th can stay on top, but then y cubed needs to go down, and z squared needs to go down. All right, and then I just plug in my numbers for x, y, and z, and so I have 5, I know my x, remember your parentheses, x is negative 1, and then I know y is 2, and z is 3. Okay. -1 times -1 times -1 times -1 is a positive 1, times 5 is positive 5. 2 cubed is 8. 3 squared is 9. We're multiplying these numbers together down on the bottom. And so we end up with 5 over 72. I cannot reduce that down, so that's where I'm stuck. Last thing here, the population of birds doubles every 8 years. The expression, this models the population of 6,400 birds after t periods of 8 years. Evaluate the expression at time 0 and at time -2. Okay, and so basically all this is asking is, so our first one, we're going to do 6,400 times 2 to the 0 power. Okay, so at time 0. And 6,400, 2 to the 0 power is just 1. And so 6,400 is our answer. Now, what is this even asking? It says describe what each value represents in the situation. The t is talking about time. T periods of 8 years. So after 0 periods of 8 years, the population is at 6,400 birds. Okay. Now, if we plug in 6,400 times 2 to the -2, okay, really what that is 6,400 over 2 squared, which is 6,400 over 4, which is 6,400 over 4, 1,600 birds. Okay, now t equals -2. What does that even mean? Well, it means that 2 periods in the past, each period is 8 years, and so basically 16 years ago, right? So 2 periods before now, 16 years ago, there were only 1,600 birds. Years ago, there were only 1,600 birds. Now, at this present moment, there are 6,400 at time 0. Okay. Last thing, evaluate this expression for these 3 numbers. I'm going to do this as quick as I can. I only have about 2 minutes left of my videos. So 500 times 3 to the -1. Well, I know that that's 500 over 3 to the first, which is just 3. So 500 divided by 3. I believe that's a fraction, but I could be wrong. Yep, it's a fraction, and we can probably just leave it as 500 thirds. Okay, now the next one, 500 times 3 to the 0. I know that that's 500. Anything to the 0 power is 1, and so my answer there is 500. And then the last one here, 500 times 3 to the second. That's the same as 500 times 9, which is, let's see, 9 times 5 is 45, and then 2 zeros tacked on, so 4,500. All right, that is section 1.